You might wonder what agents are and be a bit confused when you found no clear definition. You may also be slightly puzzled about the term agentic system, which you've seen used in hundreds of AI startups that launched in 2024. Or maybe you studied reinforcement learning and are wondering if generative AI is using that term correctly. In today's tutorial, we're going to clarify this with a bit of theory and several code walkthroughs. The video is separated into 3 main sections. First, what are the current definitions of agents out there? There are many, and spoiler, there is no exact consensus on one definition. Then we'll explore what's the difference between agents and workflow. Here we're going to check out some code from Anthropic to understand better the different variety of agentic architecture. Finally, we'll examine the claim made by HuggingFace and Anthropic that you should most likely not build a fully autonomous agent. At the end of this video, you should have a better idea of what exactly an agent is and what type you should focus on building. By the way, if you don't have much hands-on experience with modern AI engineering, I greatly recommend the learning platform Scrimba, who are kindly sponsoring this video. I'm personally a big fan of Scrimba because it has one of the best UI UX for learning coding topic I've seen. The platform is heavily focused on practical skills, and their AI engineering path make you build real applications. So there are 7 different courses that will teach you a different element of AI engineering. The first one is a good guided introduction with like good overview about like the OpenAI API. The second one will show you how to deploy your system using Cloudflare. In the third one, you're going to start to use open source model with Hugging Face. In the fourth one, you're going to start to build retrieval augmented generation application with vector database. Fifth one is all about agent. And the sixth one, we're going to start to work a bit more with multimodalities, so not just text, images also. And then the last one is a big project to make an open AI assistant. Check out the link in the description for 20% off and to check out their massive library of free content. Let's start by defining what is an agent. You'll see it's a bit harder than it looks. I'm going to read a definition for you and you're going to try to guess the date it was written. So the question, what is an agent, is embarrassing for the agent-based computing community in just the same way that the question, what is intelligence, is embarrassing for the mainstream AI community. Problem is that although the term is widely used by many people working in closely related area, it defied the attempt to produce a single universally accepted definition. This definition dates back all the way from 1995 in the book Intelligent Agent, Theory and Practice by Woolridge and Jennings. Agent is currently a very diluted term. However, right before the whole generative AI boom, the consensus for the definition of an agent was held by reinforcement learning. It was defined as follows. An agent is an entity that interacts with an environment to learn optimal behavior by taking action and receiving feedback in the form of rewards. The agent goal is to maximize the cumulative reward over time by exploring and exploiting the environment. The key component of an AI agent in that setup include state, action, reward, policy, and environment. A good modern visual of an agent in this sense is a pre-trained model like DeepSeek V3 when it's being trained to do reasoning. The agent is DeepSeek V3, the policy is the parameter, the action is the token outputted, and the environment is whatever task they are evolving in, coding for instance, with the reward feedback being deterministic like lead code accuracy. Some of these reinforcement learning techniques are used for some of the capacity of building reasoning model and non-reasoning model, which on their own are not agentic. But these reinforcement learning fine-tuned model can act like a reinforcement learning agent if set up properly in an agentic system. If you did not understand what the heck I just said, congratulations, you are normal. This stuff is confusing. So the definition of an agent is at the same level, I would say, of confusion right now as the one for AGI or intelligence. Trying to pinpoint it exactly is really a useless exercise. You kind of have to feel your way through it and use more descriptive word whenever possible than just agent. Let's take a look at a few interesting definitions from Hugging Face to get that vibe. So here's the paper. It's called Fully Autonomous AI Agent Should Not Be Developed. The conclusion is here is a bit obvious. They gathered a lot of the definition of what the AI agent is, which I found was really useful in understanding like context in which the agent name and definitions are evolving in. So we can take a look at a few of them. Here's like one of the oldest. An agent is anything that can be viewed as perceiving its environment through sensors and acting upon that environment through effectors. If we go down and we look at like more recent one, let's say 2024, we have Salesforce that says a type of artificial intelligence system that can understand and respond to customer inquiry without human intervention. In this case, like a little LLM that you prompt once could be viewed as an agent. Here from Gabriel et al. With natural language interface whose function is to plan and execute sequence of action on behalf of our user across one or more domain in line with the user expectation. So the definition kind of shifted from the academic to more of like the marketing front end of some of these companies that are selling this type of stuff. Here, one of the latest is element. A base agent can understand human instruction, make plans, explore environment, and utilize tools to solve complex tasks. This one is interesting because it kind of look back to the reinforcement learning route that this thing had. Another thing that is interesting here is that, let's say the AI agent in Azure Cosmos DB, there's this kind of idea about tools that seems to be more and more prevalent. And to be frank, like the Toolformer paper in 2023 that kind of introduced this kind of inherent capacity of LLM to be able to interface with tools if done properly, and then later on was implemented by all of the LLM providers, is kind of one of the main driver of the fact that now these things are called agent, because you go from just being answering text-based thing to having a system, an interface, the LLM as an interface that can interact with other system kind of on its own by modulating a bit like how they're making the API call. Because at the end of the day, all of this is just like natural language that you're flinging back and forth. The technique to do a Toolformer is not that complicated. There's like an open source repository about like how to do that exactly. But if you see, the basic idea is that you should fine-tune the LLM so that they know when they should be calling a tool that they know about, and then that they replace that after the fact by an API call that return back the answer, and then they replace the API call that they put. Let's say here, Joe Biden was born in, I need to do a QA API call and ask where was Joe Biden born. When the output will be coming back from like this QA system, you just change that and then remove this element and replace it by Scranton, in this case Pennsylvania, and then you return this to the user. The actual conclusion from HuggingFace here is that this is their definition: computer software system capable of creating context-specific plan in non-deterministic environment. And in their agentic level grid that they've made, you have this idea of tools being very prevalent. And it goes from like the human in control to the actual system in control. And in between, there's kind of a gradation of the level of agency an agentic system can have. So in the middle layer, you have what is calling a router or like a tool calling system. And you can see here what's in the human purview versus in the system purview. And these last part, where we have a multi-step agent and a fully autonomous agent, the human doesn't do much here. In this case, the human just say what tools you can use, and then the multi-step agent will figure out what to do. And in this case, the agent is actively coding its own tool to then be using that to do a task. What the folks at HuggingFace are saying is that these ones, you should not build them. And as we're going to see in a few minutes with the workflow and the agent separation, a workflow is this part. An agent for Anthropic is this part over here, these two gradations. Let's examine now the difference between an agent per se and a workflow. Thanks to the team at Anthropic, they managed to put some clarity and order on the term beyond the marketing hype. I suggest you to read both the blog post and watch the short interview linked in the description. Both agent and workflow are a variation of what we call agentic system, but an agentic system might not be an agent. Let's start by defining what is an agent. A single LLM is not an agentic system nor agent, it's just an LLM. When you add retrieval, tools, and memory, it becomes what's called an augmented LLM. In order to have an agentic system, you need to have multiple of these augmented LLM together and stitch them up through various combinations of flow of information. An agent is defined as a system where the LLM dynamically direct their own process and tool usage, maintaining some amount of control over how they accomplish a task. So, the human interact with the LLM, but the LLM is running unknown amount of action, up to a predefined barrier in some case, to achieve the task. If you look closely, it does look a bit like the reinforcement learning paradigm, except there is no weight update in the model. A good example of a proper agent with a definition is a coding agent. The coding agent can have some back and forth with the human, but once the context is clear, it will go ahead and use various tools, write its own code, and run it to test it. If we try to match this with the different agentic level that we saw in the HuggingFace paper, it will fit here in the last two sections. In the context of a coding agent, the model is still limited somehow with what it can do, so it's not a fully autonomous agent yet. The agent won't create its own tool in the process of achieving a task. A coding agent, however, is an important piece in the system of having a fully autonomous agent. Let's dive a bit deeper in workflow now, because in most cases, these will be the agentic pattern you will encounter the most. Workflow are defined as agentic system where the LLMs and tools are orchestrated together in a predetermined flow by a human operator. We have these 5 main patterns in use today. We are going to dive into each of them and run some code example set up by the Anthropic team. By the way, in a more complex LLM application, you might have multiple patterns like this interacting together. It's not just one of them. First, we have prompt chaining, where you have multiple very defined steps being followed, but that pass through an LLM. Each LLM has a very specific job to do in that flow. It's mainly used when you have clear subtasks because you are able to reduce the context load on each of the LLM calls you are doing. This is kind of similar to the machine learning technique called boosting in shape. Not exactly a one-to-one, but kind of the same idea. So here we are with the prompt chaining example from Anthropic. You have this core input from the user, which is a report, Q3 performance summary, then you have our customer satisfaction is blah, blah, and you have a bunch of like data point, right? And then you want with this to do a series of steps that are very well defined and linear, right? So you're gonna call the chain function that we're gonna see in a minute. The first step is an extraction process. And then the second step is a conversion process. And after that, it's a sort kind of task. And at the end, it's a final formatting, right? You could technically give this one shot to an LLM in one prompt, but like we're gonna see in a few with all of these examples, it's all about cutting the context and limiting what the LLM can do to kind of mess it up. And if you want to implement chaining here in code, it's not too complicated. It's basically a for loop where you're gonna like take the input, jam it into an LLM call, and then take the output of this and then pass it on forward. So the output of the first LLM becomes the input of the second one, and then you keep on doing this. You're not storing all of the output and then like merging them and whatever. You're just like processing this like literally a factory line. So if we look at the output of this with like a Claude model, you get like this is the input text. The first step is the extraction of the numbers. Then it's like the proper conversion of the numbers to like a percentage. And after that, it's like the sorting of all the numbers. And finally, it's the format that you want to see it. Another pattern is routing, where a first LLM decides which path to choose based on its input. This is very analogous to the prompt chaining method to reduce the context load for a task, but with multiple parallel paths that are possible. Very important here, though, not all paths are chosen at the same time, just one. So here, if we look at the setup, we have a bunch of tickets coming, and then we need to take this ticket and define where it's going to be going. Right? Is it going to be going into billing? Is it going to be going to product, account, technical? You have 4 of them that they can go and hit that route. And if let's say it goes to billing, it says you're a billing support specialist, follow these guidelines. Again, you give them a bunch of guidelines. Same thing for the technical support, it's different guideline. Same thing for account, it's different guideline. You see here we have 3 of them. So we're going to shoot 3 and then it will highlight a specific path. In the code, there's nothing too crazy that is going to happen. We have the selector prompt here that we're gonna use a F string to take our input, which in this case is the ticket. The ticket will go straight over here, right? And then you will say, analyze the input and select the most appropriate support team from these options. And then you say exactly what they are. And then it will output something in XML format in this case. And then we're gonna be able to extract the XML. Hopefully it will not hallucinate another one that doesn't exist. And then we're gonna be able to take that and then have the actual logic to route it into the right direction. We are actually doing the work of routing it into the right stuff. And then you're gonna do the LLM call on the selected prompt that you have based on the route. And this is what you're gonna give. And then you're gonna give the ticket back in there. So you give the ticket twice, right? You give a ticket to the kind of selector of which route to go to. And you will tell you have to go this route, right? Let's say billing. And then you get that, you do and format the LLM prompt so that like it's the billing prompt, and then you add the ticket in there again, shove it that into the LLM, and you'll be able to get your response, and that response is what you return. So if we look here, first ticket is can't access my account. And then the response here is that they're showing the two of them. So it says, hey, here's the available route, billing technical account product. So it's going to analyze the route here. It says, this issue is clearly related to account access. You don't have to have all of this, right? You really don't have to have that, but it may be good for debugging why the system went with this selection, right? So here they said the selected route is account. And then once the other LLM call happened with the account specific ticket, the response is the following, dear John, and then blah, 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 right? And it's a good, big, fat response that is, this one is for the account template that we've seen. And the account template here is saying, always start with account support response, prioritize account security and verification, provide clear step, include security tip, set clear expectation for resolution time. So a lot of emphasis on security. And you can see here, important security warning, security verification required, expected resolution time. So again, we're cutting the context and just feeding it now into one LLM call that has much more information. Like the system is very flexible now. You can add as many routes as you see fit, right? And it will not necessarily increase that much the complexity. And then you can group route if you want to and make a bigger complex system. But that's the gist of it. Something similar than routing, but with a different shape, is parallelization, where an input is fed into multiple LLM call in parallel. Here there are two main ideas for why to use this. First, cutting tasks that can be run in parallel, obviously. Second, using the inherent stochasticity of the LLM calls to create more robust output by collecting multiple output on the same input. This last bit is very similar to bagging in machine learning sense, where you have an aggregator at the end. Please note that in this case, you already know what the tasks are and how to aggregate them. So here we're saying, analyzing how market change will impact this stakeholder group, provide specific impact and recommended action, and format with clear section and priorities. So this is the input that goes into each of the, in this case, 4 tasks. And if you see, the 4 tasks are these ones. So customers, and then here are their priorities, and then employees, here are their priorities. So there's 4 of them. We know there's 4. There's not a 5th one that will appear out of nowhere. If we look at the parallel function, which is this thing, this is what it's using. This prompt is our input. So this is the stakeholders, right? And then you can set number of worker because you're going to parallelize that. This is not too important. So all of these are running in parallel, right? And then what you're going to do is you're going to do the LLM call, and you're going to give them the input, right? And then you're going to tell them what type of stakeholder with like the stuff that you written as a priority. And then you're going to return all of this stuff in an array that you're going to format. This is why you're going to get all of these 4s, and then it's going to be aggregated. So if you look at the output, you have this format, right? Here until there for the customer. And then this is the same thing for the employees, right? And then this is the same thing for the investors. And finally, this is the same thing for the suppliers. The exact template is not the same in each of them, right? You see this phrase happening from some, but not all of them. You might need to do like some more tweaking if you want to have like things fitting a specific template. Now we're getting to a bit more intricate setup. One of them is the Orchestrator-Worker setup. This one on the surface looks like parallelization a bit. However, you usually don't know in advance the full number of tasks or even what their input will be. That's up to the orchestrator to decide. This is also why you need to have an LLM at the end to synthesize the input of the worker, because they are not deterministic like in a parallelization setup. So in this particular case, the task is to write a product description for a new eco-friendly water bottle, right? We want to do that. And then we're going to give it some context about like what we want. So the target audience is like environmentally conscious millennials. And the key feature is plastic-free insulated lifetime warranty. And then we don't have more information than that. We don't know what we want, right? In this case, we have absolutely no idea. And we're going to let the LLM try to figure it out. And then in this latent space, find a few different angles we can use. In this case, what we're asking it is something a bit more vague, right? You can't really cut this into specific task here. You really don't know. So you're going to say, analyze this task and break it down into 2 to 3 distinct approach. So you have the task here, and then return your response in this format. So here, the analysis, blah, blah. And then you have different tone that you can use. You can use a formal tone, conversational tone, And if you see here, we're already setting it up into an XML because we're gonna extract some information from it, because this goes into an orchestrator. So this is the first one that will be hit. And then it will create multiple parallel element tasks. We don't know how much. And then once these are done and they're spawned and then they have the output, we're gonna have to bring this up into a synthesizer. So in this case, it's a good idea to structure the output format in JSON, XML, whatever, right? That work, YAML, so that you can extract the information dynamically. Here is the working prompt. So you have generated content based on, and then it will tell you the original task here, the type of task that you should go for. You see like there's a match between these and these, so you need to extract these. And then the guidelines are here, task description, and it goes over there, right? So these two match. The orchestrator and the worker need to kind of match in the formatting. You cannot let them fully loose. You need to find some interface so that they can work together. So it's called like this. So you have an object flexible orchestrator, and you're going to give it the orchestrator prompt and then the worker prompt. So this object is looking like this. So you have these strings that are initialized, and then over here you have a format function, and then the process function that is going. So if we follow the train of thought in the process, which is what we're going to end up calling in order to kind of get this rolling. So the first step is like we're going to format our prompt properly, right? With the orchestrator input. So like jam it into the template that we've said earlier with like the curly bracket. So we're going to replace some of the variable in there. And then we're going to call the LLM. And if you look at the format prompt, is you have the template and then you have the argument that you're passing, and then you're going to just like format it properly. So that's the orchestrator, and then the orchestrator will be able to decide and have a response about like what it should be outputting. And then it's all about extracting it with like extract XML. And then we're telling it exactly what do we want to extract, the analysis, the task, and then have multiple tasks over there. We're going to call parse task. The parse task is over here. You're going to take the XML and you're going to generate a list of task dictionaries with the exact format that we need to replace the red stuff in the worker template. So here we're going to go line by line, and we're going to extract the task, the type, and the description. We're going to be able to store that properly and then return this into the task variable. Once we have the task variable, now we haven't called anything. We just prepared the prompt for the different worker. We're going to check out how many workers we need to have based on the list in this task variable. And then we're going to start each of the worker one by one. In this case, it's running like sequentially. Worker goes, the other worker goes. But if you had this for like 100 different tasks, you can do and use some parallelization like we've seen before. So then you process each of the worker, you like set up the input with the format prompt properly, you call the worker here, and you get the response back. You're gonna extract the response because it's hidden into like the output. You tell it exactly how to respond to that. And then you're gonna append the result over here, and you're gonna iterate. And at some point, then you're gonna be able to synthesize the information. So if we look at the output of this, so here, this is the analysis. This is the output of the orchestrator. This task requires creating marketing copy for an eco-friendly water bottle, which represent multiple angle. Here is exactly the XML that we were able to get out. So this is like the task type here. And then here, this is the worker result for formal, right? Worker result for conversational, and a hybrid version. You see the conversational has nothing in it. Right? So this one was not able to generate anything that was that useful. So this is why there's kind of a missing step, I believe, where they could have added like the synthesizer, because they don't have it here. Here they're just like outputting the stuff. Maybe the synthesizer response is like, hey, take each of these, right, and like reformat it so that it fit like this template, and remove any of them that has gibberish. So you can only keep the worker result that makes sense, and create a report out of it. So here the hybrid one, which is I think the conversational / formal, it looked like this: meet to Aqua Verde Elite, where your daily iteration ritual become a powerful statement for our planet futures. It's kind of cool. Like it kind of matched the tone that you were looking for, but like with one prompt you get this flexibility, and you didn't decide on that part. It's kind of a bit stochastic. Depending on your tone, on like the key feature that you set here, the target audience. So pretty cool overall. Finally, we have the evaluator and optimizer pattern. The pattern creates a clear separation of concern between an LLM that creates something and another one that evaluates it based on some criteria. It's like a dance between the generator that will iteratively try to fit the specs and an evaluator that will tell the generator where to focus its attention to fit the specs better. So the last one we're going to see is an iterative coding kind of system where there's going to be one system that we're going to generate the code, another one that will try to give feedback, and then we're going to iterate until the evaluator says, yes, this is good, it passed. We're not actually going to run code with this setup, right? It's just going to be a loop where it's going to look at the text and like think if it's going to pass whatever you need to pass. So here the evaluator is that evaluate this following code implementation for correctness, time complexity, style. You should evaluate only and not attempted to solve the task. You should only output pass if all the criteria are met and you have no further suggestion for improvement. Again, here you try to put the stuff into some formatting that you can extract, XML, JSON, YAML. And here's the generator. Your goal is to complete the task based on user input. If there are feedback from your previous generation, you should reflect on them to improve your solution. So here you can put your reasoning over there, and this is important because we're gonna we can add to that, right? And here is the response where the code will be there. It's exactly like before, we're gonna be able to extract it. So the task here, implement a stack with push, pop, get, min. All operations should be O1. So this is what you're gonna give to this loop. And the code for the loop will have like it will oscillate between the generator and the evaluator. And in this case, we don't know how long it will take, right? If we knew that it takes 5 passes, you can just unroll it and do like some prompt chaining and you should be good to go. If you don't know, then this is where this loop is interesting. You can have some early stopping so that you don't like go bankrupt because this LLM is running forever. But overall, you usually don't know exactly when it should be good to go. So here we're doing generate, and there's 2 things that we're going to output: a result and some thought. So the result and the thought process that went through, and then we're going to append this into the memory, and then the memory I think is going to be passed at some point back into the context over here, and we just keep adding to the memory again and again, so that the system is not caught into like a loop where there's no memory and they don't know what the heck happened before. So they're doing the same mistake, change it a bit, go a bit to left, and then go a bit to right, and go a bit to left again. With the memory, it should not happen because you did that in the past, so you should not try this again. And you see here, we go into the evaluation loop, and then evaluation, we have the evaluation, the feedback, and then if the evaluation is passed, so this is the thing that we extracted, this XML field, we're done here, and we can return the chain of thought if you want to. Otherwise, we're just going to pass to the generator prompt and the context, so this thing over here, which has the feedback in it, and we only keep the latest feedback over there. If we look at the evaluation prompt here, it's like we take the full prompt and then we're gonna put the original task in there, and then the content to evaluate is what we like the generator gave to us, and then we're gonna do an LLM call with the full prompt. We're gonna get our evaluation, extract the right stuff, so evaluation is feedback, and then just output that. And here we're doing a print statement just so that we can debug it into our stuff. The generator has the exact same setup because we're using the same technique here. The XML is different, it's thought and response here. So if we see it in action here, the generator starts and says, here's my thought. The task require implementing blah, 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 blah. You need to have this and that. This is useful for like debugging the thing. And then we output this thing, the generated code, in the proper bracket that we need. Remember, to get that output, we're not taking the raw thing, the raw XML that it's outputting us. We're formatting it like this so that it's more readable. Otherwise, it's going to be XML over XML over XML. The evaluation start, and then the status is that I need to have improvement. And this is flexible. It can be anything, right? It can change. The only time that it's not going to be changing is when you're going to have pass. And this is fixed because this is our exit criteria. So it gives a bunch of feedback, which are then passed to the generator. So what you have here is the current thought that he has based on the feedback. I'll improve the implementation by doing all of these 4 things because this is a summary of these ones. And then you get this generated code, which is this, right? Is this a valid thing that will hit the criteria? Maybe not. Maybe the evaluator is absolutely garbage, right? So to make this even more powerful is that there's like this loop going, and then there's maybe a final loop once the evaluator says pass, which is gonna try the code out and then go back. But here we're going a bit more into like the coding agent system versus being just an agentic workflow. There's maybe a loop like this that is in the agent coding system. An interesting point to note is that in each of these flows, the goal is to reduce the context a model needs to ingest in one prompting. It's all about cutting what you give to an LLM to make sure that it's not going to diverge too much toward hallucination. So now, what happens when you remove these guardrails and let the agent fully go loose? We will not explore the claim by Anthropic and HuggingFace that you should probably not do that. Both companies are taking different angle on this question, which I found quite complementary. Let's hear it first for Anthropic.
I feel like in production, we haven't even seen a lot of like successful single agent.
Okay, interesting.
But like, this is kind of like a potential extension of like successful agents with the, I guess like improved capabilities of the next couple of generations of models. Yeah, so this is not advice that everyone should go explore multi-agent environment. It's just, I think like, to understand the model's behavior, like this provides us with a better way to understand model behaviors.
I see.
So as you can see, it seems that agents, at least at Anthropic, are still more or less a research curiosity, more than like a production-ready system in terms of business value.
I think maybe something that's not going to happen yet, going back to like what's overhyped.
Yeah.
I feel like agents for consumers are like fairly overhyped right now.
Okay, here we go, hot take.
Because I think that like we talked about like verifiability.
Yeah.
I think that for a lot of consumer tasks, it's almost as much work to sort of fully specify your preferences and what the task is as to just do it yourself. And it's very expensive to verify. So like trying to have a agent like fully book a vacation for you, describing exactly what you want your vacation to be and your preferences is like almost just as hard as just going and booking it yourself.
Interesting.
And it's like very high risk. You don't want the agent to go like actually go book a plane flight without you first accepting it.
So the team at HuggingFace was cool enough to do a full grid analysis of the different type level of agentic system there can be and their risk-reward ratio on a few dimensions. By the way, the paper is in the description. Let's take a look at the result. So here's the grid. It's in the paper. You can take a look at it if you want to. There's many dimensions, and they kind of grouped into like these buckets: safety, truth and reliability, user interaction, task performance, and broader impact. So like you can discount whatever you think that is not important, let's say, in the assessment. But they use all of this dimension, and they're over there, right? They're pretty well explained. And in blue, like the benefit outshine the risk, and in red, they think that the risk outshine the benefit. If we move all of the way to the fully autonomous setup, the main part that is problematic is on the accuracy side, because like it's a fully autonomous system, it can make up its own tool and it will usually run for a long time. So here, the issue is that it can create and act on an entirely fictional scenario without possibility of verification or correction. It will just go on the left field and diverge like crazy. At least with the multi-step and tool call, there's guardrails that you can put, like we saw with the workflows. Consistency with this system, the issue is that it's entirely unpredictable behavior chain with no way to ensure consistency across run, because like the model will just like be doing a series of divergent step in the worst case. So there's problem with acuity, flexibility, privacy here, unrestricted data access and sharing across all available source. You can think about like the system starting to emit data and then just blast this all across the internet because they find a loophole to be able to do it. That could be a dangerous setup for privacy. And similarly, in the same vein, like safety might be an issue also, security in this case. And like, because these models are kind of generative, there's no way to verify or establish trustworthiness with them. And they are made to generate. They will hallucinate for sure, in some useful way, in some bad way. So it's difficult to figure out what the truth and the fiction is in their output. So overall, they're saying that like, there's no, they don't think there's any upside of doing fully autonomous system. I think there still can be if it's in a setup that is well bounded. You can imagine like a fully sandbox environment, and then you can have them run and like do their stuff. I think it's more of a broad assessment that like that level over here, if you're reaching for it, right? The chances that you're right are very slim, right? Well, if you reach for like these system before and then you work on them first and foremost, you're gonna hit your use case, and then you're gonna have a better trust that the system is not doing any harm. So if you're building an AI application, it's almost guaranteed you are building a workflow and should really steer away from a fully autonomous system. If you do find yourself reaching for the full agent setup, maybe just think about it twice. Remember, at the end of the day, these systems are made to generate, and you are trying to control a bit their context, so they do not do that too much. To wrap up, here is a nice explanation from Jan LeCun of the shortcoming of the current generative model and why the fact that they are divergent yield like the risk that we've seen in the HuggingFace paper.
That process is basically divergent. Every time you produce a token, there is some chance that the token is not within the set of reasonable answers and take you outside the set of reasonable answers. And if it does that, there is no way to fix it afterwards. And if you assume there is some probability for that, wrong token, for wrong tokens to be generated, and the errors are independent, which of course they're not, then you get exponential divergence, which is why we have with those models hallucination issues.
So I hope you enjoyed the video. Don't forget to like if it was the case and leave a comment if you have any questions. I'm here to help. Have a great week everyone, and see you in the next video.